how are you? Hello students, how are you? I hope you all are good. Now see here, from our inorganic chemistry we are starting our first topic, that is coordination compound. And you deal, I know, you deal some compounds in redox reaction topic, and you remove what oxidation number of that. Okay, so we will start our topic, that is coordination compound. So see what will happen in coordination compound. So what is the coordination compound? So very much important is means it is used in medical chemistry, okay, in electroplating. So variety of uses of our coordination compound, so we will discuss here. So you can write here whatever definition of this our topic, that is coordination compound. So see here, when say when metal atoms when metal atoms are bound to bound to a number of anions, or neutral molecules. Okay, when metal atoms are bound to number of anions or by neutral molecules by sharing of, yes, by sharing of electrons. Okay, by sharing of electrons. Now see here what will happen by sharing of electrons, or we can say this part, but this sharing of electrons in modern terminologies we call it as a what, coordination compounds. Okay, so see here, most important part is what, now as you know, chlorophyll. See here beta, chlorophyll, then hemoglobin. Okay, chlorophyll, hemoglobin. Okay, then as you know, vitamin B12. Okay, so see chlorophyll beta, which element mainly in complex form? Magnesium metal. In hemoglobin is what beta? Yes, iron. When vitamin B12, what beta? Yes, cobalt. Means these are also what beta here? Coordination compounds. Okay, in that your magnesium metals are bonded to a number of anions or neutral molecules by sharing of electrons. Now in iron also, means hemoglobin, and in cobalt also. Okay, so here like that, how most important is our whatever coordination compounds. Okay, see here, we will discuss here first, that is addition or molecular compounds. Okay, so see here, addition or molecular compounds. So addition or molecular compounds, what we can write here? See definition: compounds which are formed by the, see, the compounds which are formed, say, the compounds which are formed by the combination, yes, combination of simple salts, combination of simply, or we can say here combination of simply, addition of two or more simple salts, two or more simple salts. Okay, the compounds which are formed by the combination of simply addition of what, two or more simple salts. Okay, so these whatever we can further classify as a addition or molecular compounds. So see how we can classify it with a, here we can write as a double salts. What, double salts. Okay, now how your double salts are formed? Okay, so these are formed by the combination of two or more simple salt. How double salts are formed? These are formed by the combination of simple two or more salt by the combination of two or more simple salts in equimolar proportion. In what? In equimolar, yes, in equimolar proportions. Okay, so whatever I am writing here, so you have to write in your notes. Okay, it is very much important. Equimolar means means similar, similar moles. Okay, in proportion what? Similar moles. Now we will discuss here some properties. Okay, in double salts we will discuss here some properties of the salts. Okay, what is the properties of double salts? First we will discuss on dissolving water. They dissociate completely into its their constituent water. Okay, see, on dissolving in water, on dissolving in water, they okay on dissolving water they dissociate into its constituent ions. Okay, constituent ions. So second property, they give positive taste. Okay, so you may write here, they give what? Yes, positive taste for each ions present in, okay, they give positive taste for each ion present in that particular salt, in that salt means C. Either double salt property is what? On dissolving water they dissociate into its constituent ions. Okay, and they give positive taste for each ions present in them, or you can say present in that particular salt. Okay, so these are what here we can say as a properties of double salt. Okay, so see here, uh, one more we can write here. Okay, after these properties, see, we will see here one example. Okay, how it will act like a property. See, as you know beta, suppose if you are taking example KCl dot MgCl2 dot 6H2. Okay, so as you know how it dissociates, so how it dissociate, yes, K plus is Cl minus, okay, plus what beta, Mg2 plus, okay, like that it will dissociate. Okay, means they are giving positive taste for each and every ion present in that salt. Okay, obviously because they are dissociating, completely dissociated into its ions, so obviously they are giving what? Positive taste. Okay, so see here we will discuss here beta, and one more we can write here third property regarding this double salt. They cannot maintain their identity. Yes, very much important. They cannot maintain their identity in aqueous solution. In aqueous solution, because they are completely dissociated into its water. Understood? Okay, so we will see here second coordination compound. We will see regarding coordination compounds. Okay, we will see regarding coordination compounds. So as you know what are the coordination compound, we saw examples also. So see, the compounds which maintain identity in aqueous solution. Okay, the compounds which maintain, yes, identity in aqueous solution. How they maintain identity in aqueous solution? Because they does not completely dissociate into its water. Okay, understood? Or you may write here beta as a first property, they does not dissociate. Yes, they does not dissociates completely in aqueous solution. Yes or no? Correct. Second, it does not dissociate completes in aqueous solution. Okay. Now, okay. Now see, one more important fact here is what? So they does not give positive taste of each and every ion present in this coordination compounds because they are what? Incomplete dissociate. Understood? Now suppose if you are taking example here of one coordination compound, that is K4FeCN6. Okay, K4FeCN6. Now here, now we will say we will observe here whatever coordination compound I wrote. Okay, so whatever in square bracket. Okay, so this square bracket we call it as a what? Coordination. Yes, coordination sphere. And जो भी कुछ बाहर है means either here, okay, or either here, okay, we call it as a what? Ionization sphere. We call it as a what, beta? Either this side or either this side. We call it as a what? Ionization sphere. Means whatever these ions present here or either here, they can displace. Understood? And whatever coordinate sphere means here, say you can observe here, it is a metal ion which is directly bonded to a this. Okay, it is a metal atom. These are directly bonded to the either anion or either neutral molecule. So we togetherly we call it as a what? Coordination compounds. Okay. So see here, these are what our regarding as an example of coordination compound. See, we will discuss here next part. Now one more thing here you have to keep in mind, that is never your coordination sphere is means ionized. Only whatever say this coordination sphere never ionized. Either this part or this part your ionize. Okay, it is very much important part. Okay, now suppose if you are dissociating this K4FeCN6, so how it will dissociate? Yes, okay, K plus, okay, so 4 here crossover valency like this, FeCN6 what beta 4 minus, okay, K plus FeCN6 4 minus. Okay, so here we can write here as a simple cation, means we can again differentiate this. Okay, this what beta as a what you will get? Simple cation here you will get, and what? Complex anion. Understood? Means K plus is what? Our simple cation, and these are what? Complex anion. Okay, now again we can differentiate. See, suppose if you are taking as another example, say beta cobalt NH36 and Cl3. So what you will get here on dissolving in water? Suppose if you are dissolving in water, okay, NH36, so this crossover valency, so 3 plus what beta 3Cl minus. Okay, so here we can write it as a complete, suppose see K plus, okay, and what here like that, here K plus and FeCN6 4 minus, so here what? Cu means crossover valency. Okay, so 3Cl minus. Understood? So here what you will get? Here you will get now reverse of this, means complex what? Complex cation part you will get here, and here what? Simple anion. Understood beta? What is going on here? Okay, you will get what? Complex cation and simple anion you will get. Okay, now here one more example you may mention, that is, say, suppose I will write like this: pt nh3 4. Okay, pt nh3 4 and ptcl4. Okay, so in this case you must know, here you have to show, you have to write some common oxidation number of that particular metal. Okay, so as you know here, what these are, what platinum is what, metal ion. Okay, now see, either platinum, they are showing two common oxidation state. Okay, which are those? +2 and +4. Now suppose if you write here +4, then this what becomes Cl minus, so whatever platinum oxidation becomes 0. Therefore one more important oxidation number, common oxidation number of your platinum is what? +2. So you will get first part is cation and second part is what? Your anion. So +2 and -2. Understood. So how it will dissociate? It will dissociate into this +2 and is -2. Means here in this case, what you will get here? Complex. Okay. Complex cation and what beta? Yes. Complex anion. Complex cation and complex anion. Now you may here say, you may you can distinguish, say, after combining or after dissociating this, what you will get? Yes, you will get what? Simple cation, this complex anion, here what? Complex cation, simple anion, here what? Complex cation, complex anion. Understood? So these are examples of your cationic part and anionic part. Okay, now we will discuss beta basic terminologies. Okay, these are basic terminologies are very much important. Means we can say the backbone of this topic. Means whenever basic terminologies are came, means basic terminologies we saw in every topic. Okay, basics, for suppose example, thermodynamics, in that also we saw basic terminology, system, surrounding, universe. Okay, like that here also what some basic terminologies are there. Okay, so write down that basic terminologies related to coordination compounds. Basic terminologies. Okay, so first, central metal atom. First what beta? Central metal atom. So it is very much easy. Central metal atom is metal which accept electron pair. Okay, central metal atom is what? Which is accept electron pair. Okay, electron pair from the other molecules or atoms to form a coordinate bond from the other molecule. Okay, from the other molecule to form what? Yes, to form here coordinate bond. Okay, so generally here what will happen? Generally D block metal act as a central metal atom. Very much remarkable statement. Generally D block elements act as a what? Acts as a central metal atom. Okay, and why it is like this? Due to, so these also reason are very much important. Due to small size, okay, high nuclear charge. What beta? High high nuclear charge. Okay, one more here we can mention, that is third. See, non-availability, non non-availability, not availability. Sorry, availability of d orbital electrons. Availability of d subshell electrons, or we can say d orbital, availability of d subshell electrons, or availability of vacant. Okay, vacant d subshell. Okay, so see here, second term we can write here, second term, that is ligands. I hope you are writing everything. Okay, whatever I am here discussing, each and every word you have to capture and you have to write it in your notes. Understood? So see here, second basic terminologies is what? Ligand. So here in basic terminologies, that is in ligands, say these are the atoms or group of atoms. Okay, so these are what here? What is a ligand? So see, ligands are what? These are the atoms or group of atoms which can donate their electron pair. We have to write, these are the atoms. These are the atoms or group of atoms. Okay, group of atoms which can donate their electron pair to central metal atom to form what? Coordinate bond. Okay, so see here, it is, for example, suppose if you are considering as this metal, and this what is a ligand, it contain what? Lone pair. So this lone pair they are sharing with this metal, central metal, and forming what? कुल मिला के हमको क्या मिलता है इधर? Like this condition. Okay, means whatever ligand they are donating their electron pair and metal is accepting that electron pair. Okay, and in between जो कुछ भी तैयार हो रहा है इसको हम क्या बोलते हैं? Coordinate bond. Okay, coordinate bond. Okay, so on the basis of number of donor sites, okay, like that here one donor site means one lone pair, one donor site, or either negatively charged. Okay, on the basis of number of donor site, the ligand can be classified into following types. So ligands also here classification. Okay, so ligands also classification. So we call it as a ligand classification as a denticity of ligands. What beta? Denticity of ligands. Okay, means suppose one lone pair or as a one. So carefully listen to this. One lone pair, one negatively charged. Okay, or simple as a one molecule. Okay, so we call it as a what beta here? Denticity means suppose one lone pair. Okay, monodentate ligand, like that. Say one negatively charged, or if any compound two negatively charged, then bidentate or didentate ligand, like that the denticity of ligand. So we can write here as a definition of this denticity of ligand also, the number of donor sites. See, the number of donor sites present in molecule, okay, which can form a coordinate bond, with the central metal atom, with central metal atom it's called as it's called as denticity of ligands. It's called as denticity of ligand. The number, it is on the basis of number of donor sites present in molecule. Okay, so here, so basically I told हम उसके whatever that ligand हम उसके चार्ज के ऊपर भी क्लासिफाई कर सकते हैं. Suppose one negative charge monodentate, two negative charge, like that. Okay, positive, negative, or either neutral. Okay, so we will see here whatever types. Okay, okay, monodentate, denticity. Okay, monodentate, bidentate, or polydentate, tridentate, tetradentate. ठीक है, see here. Okay, first monodentate ligands. Monodentate ligands. Okay, so see here in monodentate ligands which having one donor side. Simple. Monodentate ligands are what? Which having one donor site. One donor site. These are what? As a monodentate. In that, suppose if you are considering anionic ligands, or we can write as a negatively charged ligand. So as you know, Cl minus, F minus, Br minus, I minus. Okay, in some cases beta, NO2 minus, OH minus. Okay, so these are what? Anionic monodentate ligands. Anionic monodentate ligands. So see here, suppose if you are considering examples of neutral ligands. So in neutral ligands, see water, then ammonia, then carbon monoxide, not cobalt, is what? Carbon monoxide. No charge on this all compounds. वाटर पर भी कोई चार्ज नहीं, अमोनिया पर भी कोई चार्ज नहीं, either positive negative on the carbon monoxide also. Therefore we call it as a what? Carbon monoxide. ठीक है. Now say cationic ligands. Cationic ligands. So cationic ligands, say here NH4 plus NO plus nitrosyl, then ammonium cation also there. Okay. Now suppose if you are considering examples of bidentate ligands, okay, bidentate ligands. Now in bidentate ligands which having two donor sites, yes or no? Which having two donor sites. Okay, two donor sites. So here you can mention two donor sites. See, oxalate. What beta? Yes, oxalate ion. So oxalate ion, as you know, yes. Say double bond O, this negative part. Say double bond O, this negative part. Two negative charge, that's why what? Oxalate ion. Simply some cases we can write, or OX, we can also call it as OX, as a oxalato ion. Okay, one more we can write here EN, that is ethylene diamine. Ethylene diamine. ठीक है, ethylene diamine. See here formula CH2NH2, CH2NH2. Okay, lone pair are there. CH2NH2, two lone pairs are there. Understood? Two lone pairs are there. Ethylene diamine, or simply here we can call it as a EN. EN is what? Ethylene diamine. Understood? So these are what here as examples of beta monodentate and bidentate or didentate ligands. Okay. See next we can write here tridentate. Okay. So see tridentate ligands. So in tridentate ligands, as you know, yes, three donor sites. Okay, three donor sites. So in three donor sites, we can write as an example here NH CH2 NH2, and here what CH2 NH2. So you can observing here three donor sites. So we can write here diethylene triamine. What will be the name of this? Diethylene triamine. Okay. Diene. Okay. Now say as an example of tetradentate. So you can write as an example of tetradentate ligands here. Tetradentate ligands beta. Say in tetradentate ligands you can write say triethylene tetramine. It's examples of what? Triethylene tetramine. Okay, so you can write formula also. Okay, NHCH2 NH2. Here what? CH2 NH, and here what? CH2 NH2. 1, 2, 3 and 4. Okay, so triethylene tetramine means 4 total donor sites. As an example, you must write here. Okay, as an example, you have to write this all tridentate, tetradentate from first onwards. Okay, from first onwards you have to write this all. Okay, now we will discuss here. Say, now we will discuss beta as a example of polydentate. Okay, after this you have to mention next denticity, regarding denticity, that is yes what beta polydentate ligands. Okay, so we will start polydentate ligands. As an example, you can write EDTA. Okay, EDTA is what? Ethylene diamine. Okay, ethylene diamine tetra acetate. Ethylene diamine tetra acetate. It is what? EDTA. Okay, so you can mention here our structure also. See as like this your structure NCH2 and means what? Ethylene diamine. So here what beta? Yes, here what? Tetraacetate. So CH2COO minus. Okay, and here what? CH2COO minus. Understood? And here also same. CH2COO minus. CH2COO minus. These are what? Yes, these are what beta? Ethylene diamine tetra. See tetra 1, 2, 3, 4. Tetraacid, and these are what? Hexadentate ligand. Hexadentate ligand. Total 6 donor sites. 1, 2, 3, 4, 5, 6. Understood? I hope you understood whatever I am writing here. Okay. tetradentate, polydentate, okay, hexadentate. Now see, we will now after this ambidentate ligand. What beta? Yes, you have to concentrate on now ambidentate ligand. I hope you understood this all or and you note down in your okay you note down in your notes. Okay, so see here ambidentate ligands. Ambidentate ligands. So here see in ambidentate ligands. These are the bidentate ligands. Write down here, beta. These are didentate, or you can write as a bidentate ligands. Okay, which form coordinate bond, which form coordinate bond which can form coordinate bond through one donor, say, which can form coordinate bond through one donor site at a time. Means here, suppose if you are considering as an example ambidentate, okay, cyanide ions. These are what beta Cn minus cyanide ion. So it can act as it can behave from both these sides, but it can form coordinate bond through at a time from one donor site only, through one donor site at a time. Okay, Cn minus cyanide ion. So see, as like this, when they are coordinate from carbon, okay, so we can call it as a what? Cyano, and when they are joining with nitrogen, okay, when they are joining with nitrogen, we call it as a what? Isocyano. Okay, isocyano. Understood? Means ambident as an example is what? It can donate from both the sides, but at a time from the one side only. Okay, either from carbon or either from nitrogen, as like this. So there at that time their names also will change. Understood? Okay. So see here another examples also there. HCl minus CSCl minus thio NCS, okay, isothiocyanate, ठीक है. NO2, see another also beta, NO2 minus, we can call it as a what? Nitro, okay, and ONO we can write as a nitrite. Okay, but here in this coordination compound we write like this, nitrito N, because it is bonded through nitrogen, and here what? Nitrito O, because it is bonded from with oxygen. Okay, I hope you understood this all. Okay. Now see here one more ligand, in denticity. Okay, denticity of ligands means our ligand only going on. Okay, whatever our third terminology here, ligands, regarding ligands. Okay, see, flexidentate ligand. So what is the meaning of this flexidentate ligand? So basically ये ज़्यादा पूछता नहीं है, but they may ask आपको पता होना जरूरी है इधर. What is the flexidentate ligand? So write down. These are the polydentate ligands which do not necessarily use all their donor sites. Okay, these are polydentate ligands. Polydentate ligands. Okay, which do not, which does not necessarily use all the donor sites, all their donor sites to form coordinate bond with the central metal atom, which does not necessarily use all the time all the donor sites to form coordinate bond with the central metal atom. Example you can write here as ADTA. Okay, so these are what as a flexidentate ligands. Understood? So it is very much important all the parts we discuss here. Basic terminology means first we discuss what is the meaning of coordination compounds, where we can use so wide variety of it. In medicinal industry so much very much important use of this coordination compound. Okay, thereafter we discuss whatever what is the basic terminology, central metal atom, ligands. Okay, there we discussed identity. Okay, I hope you understood all this content and you removed notes also. You revise all the notes whatever you wrote, and you can share on your WhatsApp. Okay, if any doubts, you can feel free to ask. Thank you very much.